Okay, so hyperbolas are very similar to ellipses when it comes to working it out. But if you look at this picture, this is what a hyperbola looks like and how it's formed. So with the ellipses, we had a cone and you had a plane that was going kind of intersecting it at a diagonal. Here, you're taking a plane and intersecting it perpendicular to the cones, and so this is the shape that's formed. So it's almost like two parabolas looking opposite directions. So the main difference between an ellipse and a hyperbola is that a hyperbola has a minus sign between the x squared and the y squared. So this is the only conic section that's going to have a minus. So the moment you see a minus, that's a hyperbola. Okay? So you're still going to have horizontal versus vertical. The difference here is that your a squared is always going to be the first denominator. It's no longer going to be which one's the greater number. Okay? So you're going to have to keep that separate in your head when you're doing all these conic sections. Ellipses, a squared was always the greater denominator. Hyperbolas, it's always the first denominator, regardless of it being bigger or smaller. Okay? So what determines the direction is whichever variable comes first. So if x comes first, then that's going to be horizontal. If y comes first, that's going to be vertical. Okay? And then, of course, you've got your minus there. So with ellipses, I taught y'all that whenever you do your c squared equals a squared minus b squared, that minus was the opposite sign of your formula. So with hyperbolas, if I have a minus in my formula, my c squared, I'm going to use a squared plus b squared. So in order for you to keep it straight, just always know that's going to be the opposite of the formula you're using. Okay? Now you're still going to have center HK, your vertices. Now we're only going to look at what we have been considering the major vertices. So the VB that we were doing with ellipses, we're not going to have that in our work for hyperbolas, because what that's doing is, if you look at this diagram down here, so your major vertices would be right here, which is for what you use for your A. Your B would be in this direction, and this is really all that it would form is like a little rectangle. And this would be your B, and that forms the conjugate axis. We're not going to talk about that though, okay? I don't believe y'all talk about that in pre-cal, so we're not going to talk about it right now, okay? So we're only going to have our two vertices. We're still going to have our foci. All right, now whenever we did it with ellipses, I told you it's inside your shape, right? Your foci was always inside your shape, and it was along the major axis. So here, with it being inside your shape, it's going to go further than what your A value will give you. Okay, so remember your A is the distance from the center to the major vertex. Your C will be the distance from your foci or focus to your center. Okay, so that C will be larger than your A because it's got to go in the curve. Does that make sense for you to visualize it? Okay, so the difference between hyperbolas and ellipses, if you notice, we've got asymptotes that we're going to create. Okay, so we've got to know the slope of our asymptote. Remember that slope is the change in y over the change in x. That's what we teach in Algebra 1. The change in y over the change in x. Now these formulas have b over a and a over b. You don't have to memorize which one is which, as long as you can understand change in y over the change in x. So if I'm looking at a horizontal hyperbola, the change in y, I'm going to find my y, the square root of that, so my b, over my a. That's how we get b over a, versus for a vertical, when you do change in y over change in x, that's why you're doing a over b. Does that make sense? Y'all see that? So if you always know change in y over change in x, it's the square root of the number under your y over the square root of the number under your x, regardless of the direction. Okay? Now your equation of the asymptotes, we're going to do that in point slope form. So y minus k equals plus or minus m times x minus h. So remember, point slope was y minus y1, equals m times x minus x1. So all you're doing is using your center hk and the slope that you just calculated or found, okay? Now, we don't have to solve that for slope-intercept form because if you look at these, you can start at the center and just use your slope, and there's your two asymptotes. You don't have to take the time to solve, because then you would have to do the positive slope, then you would have to do the negative slope. So you're going to end up wasting more time solving that in the slope-intercept form than just picking the center and using your slope in the positive and negative direction. Okay, so that's how we're going to do it. Y'all have any questions? Okay. Alright, so our instructions are pretty much the same. We're going to get it into the correct form, state the direction, the center, the vertices, foci, and now the equations of the asymptotes. Then we're going to graph, and you are still not required to graph the foci. Okay? So if I have 9x squared minus 16y squared equals 144, I do not have an x and a y term. I just have x squared and y squared. So all I'm going to do is want to make sure it's equal to 1. So I'm going to divide all three of those by 144. 9 over 144 is going to give you 1 over 16. So I've got x squared over 16 minus 16 over 144 is going to be 1 over 9. So y squared over 9 equals 1. Okay, so remember, whichever variable comes first dictates the direction. So x came first, so it's going to be horizontal. My center, I don't have an h and a k written, so it's going to be at the origin, 0, 0. So my a is always the first denominator, so the square root of 16 is 4. My b is the square root of 9, which is 3. For c squared, I've got a squared, which is 16, plus b squared, which is 9. 16 plus 9 is 25. So c is the square root of that, which is plus or minus 5. Okay? So to find my vertices, I'm going to start at my center. We said it's horizontal, so I'm going to go left 4 and right 4. So that's going to put me at negative 4, 0 and positive 4, 0 for my vertices. Okay. Now my foci, I'm going in the left and right direction, so it's going to change my x. So 0 plus or minus 5. So I can actually have two ordered pairs here because it worked out to be a perfect square. So that would give me negative 5, 0 and 5, 0. Now, I've got to figure out the slope of my asymptote to write the equation of the asymptote. So if we're doing the change in y over the change in x, my y is over the b, so that's 3 over, my x is over a, which is 4. Okay? Y'all follow that? Alright, then in point slope form, we've got y. You would have minus 0, but you don't need to write that. So it can just go straight to y equals plus or minus my 3/4. Again, here you would have x minus 0, which you don't need, so just have y equals plus or minus 3/4 x. Okay, so in order to graph it, I'm going to start at the center, and I'm going to go up 3 to the right 4. You can either use your ID, if you want to get up and get a ruler, you can. For your notes, just draw as straight of a line as possible. It's an asymptote, so it's going to be a dashed line. So that's my positive 3/4 x, and then I'm going to go in the negative direction for a negative slope. I'm going to go up 3 to the left 4. So remember that an asymptote is the line that your graph approaches but never crosses. So we're going to use our asymptotes to guide us in the shape of our hyperbola. So all we're going to do is start at the vertex and just go pretty close to those asymptotes. And that's all you have to do. You're good with that? So the next problem, I've got 4x squared minus y squared plus 24x plus 4y plus 28 equals 0. I'm going to go ahead and group my 4x squared plus 24x. When I look at my y squared and my 4y, I've got a minus here. We know we have a minus in our formula. So when I do the minus, I'm going to change the sign of that 4y because I'm basically taking that negative out as a GCF. Okay, so when you do that, you're going to change the sign of the y term. So that's going to turn into a negative 4y equals, move your positive 28 to the right of the equation, so it's going to be a negative 28. This will be a common mistake. So when you take that negative and you make that minus outside of your parentheses when you group your y squared and your y term, you have to change the sign. So then I can now factor out a 4 as my GCF for x squared, and I get x squared plus 6x. Minus, I don't have a GCF between my y terms. So now all I have left to do is complete the square. So I'm going to have x squared plus 6x, take 6 divided by 2, and I get 3. 3 squared is 9. Do the same thing for y. So y squared minus 4y, take negative 4 divided by 2, gives me negative 2. Negative 2 squared is positive 4. Now remember that when you are you're completing the square, what you write on the right side, you've got to factor in and include that GCF that you took out. So 4 times 9 is going to give me 36. And then a negative 1 times 4 is going to be a negative 4. Okay, so I've got 4 parentheses. My factored form is x plus 3 squared minus y minus 2 squared equals negative 28 plus 36 minus 4 is going to give me a positive 4. Now, when you are doing your work, I want to see this right here. I assume that y'all would know that, but I've been seeing that on the quiz where it just jumps from negative 28 to 4. I've got to see what's happening in the middle. Okay? Now, I need this equal to 1, so I'm going to divide by 4. So my equation is going to be x plus 3 squared over 1 minus y minus 2 squared over 4 equals 1. Make sure that if you are dividing and you get a 4 over 4 or 5 over 5, you put the 1 as the denominator. Okay, so my x came first, so that's horizontal. Where's my center? Negative 3, 2. So my a squared comes first. It's 1, so a is equal to 1. B is the square root of 4, which is 2. C squared is 1 plus 4, which is 5. So c is equal to plus or minus square root of 5. So I'm going to plot my center at negative 3, 2. It's horizontal, so I'm going to move left 1 and right 1. So that's going to put me at negative 4, 2 and negative 2, 2. Now my foci, also horizontal, it's happening to my x, so I'm going to use negative 3 plus or minus square root of 5, comma 2. Y'all good so far? So then to find my slope of my asymptote, I'm doing the change in y over the change in x. Well, y is over 4. Square root of 4 is 2. Change in x, 1. So it's just plus or minus 2. Okay? So my asymptote in point slope form, y minus 2 equals plus or minus 2 times x minus a negative 3 turns into plus 3. Okay, so I'm going to start from my center, and I'm going to go up 2 to the right one, up 2 to the right one, and then I'm going to do my negative 2 slope, so up 2 to the left one. Okay, and then I'm going to use those asymptotes to guide my curves. So there's my hyperbola. Y'all good with that? Any questions?
For the y minus 2 equals whatever, how'd you get the x plus 3?
That's the, you use your center, you use your HK. So really what it's going to look like is your y, see how it's y minus 2, it's going to look like that on the left, equals plus or minus your slope. Take that, and it's here, pretty much. Alright, example 3. Notice how your y squared comes first this time. That's going to stay first in your work. So that indicates that I'm going to have a vertical hyperbola here. Okay? So I'm going to group 9y squared plus 54y minus 4x squared. Now remember to change the sign. That plus 8x turns into minus 8x equals, move the 41, gives me negative 41. Okay, factor out my 9, and I've got 9 times y squared plus 6y minus, factor out a 4, leaves me with x squared minus 2x equals negative 41. Complete the square. Y squared plus 6y, 6 divided by 2 is 3, 3 squared is 9, minus 4 times x squared minus 2x, negative 2 divided by 2 is a negative 1, 1 squared is positive 1. So when I add that to the right side, I've got to take my 9 times 9, and that's going to give me 81, and negative 4 times 1, which is a negative 4. Get it into factored form, so I've got 9 times y plus 3 squared minus 4 times x minus 1 squared equals Negative 41 plus 81 minus 4 is going to give me 36. Get it equal to 1, so I'm going to divide by 36. So I have y plus 3 squared over 4 minus x minus 1 squared over 9 equals 1. So we already talked about how y squared came first, so that's going to be a vertical hyperbola. Your center is going to be 1, negative 3. So you go with your h, then your k. 1, negative 3. Okay, so my a squared is still going to be my first denominator no matter what. So my a is equal to 2. My b is equal to 3. C squared is equal to 4 plus 9, which is 13. So C is equal to plus or minus square root of 13. Now my slope is the change in y. So this time it's going to be a over b because y is over my a squared. So it's going to be 2 over 3. Alright, so my center is at 1, negative 3. It's vertical, so my a is 2. I'm going up 2 and down 2. So my vertices are going to be at 1, negative 1, and 1, negative 5. Now my foci, it's vertical, so it's happening to my y. So my foci will be 1, comma, negative 3, plus or minus square root of 13. So my equation of the asymptotes, y minus negative 3, which turns into y plus 3, equals plus or minus 2/3 times x minus 1. Because it's y minus k equals plus or minus the m times x minus h. So from my center, I'm going to go up 2 to the right 3. Then up 2 to the left 3. Go from my vertex. Use the asymptotes as your guide for the shape of the curve. And then you're done. Y'all good with that? Any questions? Alright, now, if I give you characteristics of the hyperbola and now a graph, we've got to be able to come up with the equation of the hyperbola. So, it tells me my vertices are at 1, negative 7 and 1, 5. So I'm going to plot those points. Just by knowing that, what type of hyperbola do I have? Vertical. So that tells me what variable is coming first. Y. Okay, and I know that my center If my asymptote is y plus 1 equals plus or minus 3 over 2 times x minus 1, from that asymptote, I can get the center, which is 1, negative 1. So for my equation, I know it's going to be y plus 1 squared minus x minus 1 squared. So 1, negative 1 in my center. So my a value, I can calculate by going from negative 1 to negative 7 or negative 1 to 5. And what is that distance? 6. That is my a value. So a is equal to 6. So I know my first denominator is going to be, bless you, 36. Now, from my asymptote, I can get the slope, which is the change in y over the change in x, right? Well, it tells me that it's 3 over 2. Now, if I look at the change in y went over my a value. My a value is 6. So I need to figure out what is my b value. Well, if it's 3 halves, what's that equivalent to? 3 halves is equivalent to 6 over 4. So b is equal to 4. So b squared is going to be 16. You understand that? Okay. So you are not going to have a quiz over hyperbolas. Next class will be parabolas. We're going to do horizontal and vertical parabolas. You will have a quiz after that over hyperbola and parabola. Okay? And then we'll have solving systems of quadratics, review, and test. Okay?